Hello everyone, welcome to the course Computer Networks. This is S. Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about transmission media in physical layer. That is part 2. In previous session, already we discussed about what is transmission media, what are the different types of transmission medias like guided transmission media and unguided transmission media. Guided and unguided transmission media. These two are we are going to discuss in previous session, and now we are going to discussing about what is unguided transmission media, what are the different types of unguided transmission media. Briefly, we are going to discussing in today's session. First, let us see the overview of today's session. First, we are going to discussing about what is unguided transmission media. Introduction about the unguided transmission media. What are the different types of unguided transmission media like broadcast radio waves and microwaves, infrared waves, cellular radio waves, satellite communication waves. These are all the different types of unguided transmission media we are going to discussing in today's session. First, let us see the introduction about the unguided transmission media. Where exactly we are going to use this unguided transmission media. In previous session, already we discussed whatever data is coming from the physical layer from the sender, that is going to be formed in the form of zeros and ones, that is bits. These bits are going to be converted into the signals. The signals are going to be passed from this transmission medium to the receiver. This transmission medium is either it may be cable or air. If it is a cable, then we can call it as a guided transmission media. If it is in the form of waves, that we can call it as a unguided transmission media. This unguided transmission media is also called as a wireless transmission media and unbounded transmission media. These are the names of the unguided transmission media. This unguided transmission media is nothing but the wave. Whatever data is going to be transferred from the sender to the receiver, that is in the form of waves. This is in the form of waves. These waves are going to be sent in the form of frequency. Means whatever waves are there that are going to be travel through the medium from one location to the another location. Means from sender to the receiver. This wave is nothing but it is a transfer of the energy. This energy usually in the form of matter, it is called as a medium. This is called as a medium. It is a special type of the wave that can travel without a medium, that called as a electromagnetic waves. That is EM waves, electromagnetic waves. Whatever waves are those, these are called as the electromagnetic waves. These are like radio waves, microwaves, satellite waves, infrared waves. These are the different types of unguided transmission media. So, unlike sound waves, water waves, these electromagnetic waves does not need a fluid or a solid or even air to help them to travel from the one place to another place. We are going to use as a electromagnetic waves. These waves can travel across the great vacuum of the space. So, which is why we can see the light from the distance of the stars and planets also using these electromagnetic waves. At the same time, these electromagnetic waves mainly formed when electric field comes in contact with the magnetic field. So, it is called as the electromagnetic waves. So, these electromagnetic radiation in the form of energy that is all around us to take many forms. These forms are nothing but radio waves, microwaves, X-rays, gamma rays. These are all comes under the electromagnetic radiation. So, sunlight is also called as the electromagnetic energy. So, this electromagnetic energy in the form of sun that comes to the earth in the form of radiation. That is also one type of electromagnetic energy. This electromagnetic spectrum mainly describes the wide range of different electromagnetic waves. This is about the unguided transmission media. Let us see the different types of unguided transmission media now. So, these are the different types of unguided transmission media. It is also called as the wireless media. So, these are the different types like microwaves, radio waves, cellular waves, infrared waves and satellite waves. These are the different types of the unguided transmission media. Unguided means where we cannot install the cables. There we are going to use the unguided transmission media. Unguided means there is no connection. Means there is no cable connection, that is only wireless connection in the form of waves, electromagnetic waves only we are transferring the data. So, unguided transmission media, these are the different types, right? This is microwaves, radio waves, cellular, infrared, satellite. These all are mainly based on the frequency we are going to use these waves. Based on these all are electromagnetic waves only having different frequencies. Means in each and every wave, we are going to use the different frequency for transferring the data between sender and receiver. Sender to the receiver, we are going to use the different frequency. That is about the unguided transmission media. So let us see one by one briefly. First, we will discuss about what is broadcast radio waves. Where exactly we are using broadcast radio waves. The speed of these broadcast radio waves is 1 Mbps to 10 Mbps, means 1 megabits per second to the 10 megabits per second. So these radio waves are the electromagnetic waves. Mainly it is having the wavelength as 1 millimeter to 100 kilometers. That is the wavelength speed. At the same time, the frequency is 100 gigahertz to 100 kilohertz. That is the frequency. This radio frequency, it is easy to generate because it has having the large wavelength. At the same time, it is can also travel the long distance also. That's why it is easy to generate. At the same time, these radio waves mainly generated by the radio transmitters, and these are going to be received by the radio receivers. So, here we are going for transferring the data, we are going to use the transmitters. For receiving the data, we are going to use the receivers. These radio stations, for transmitting the radio waves, we are using transmitters. For receiving, use the receiver that is going to be installed in our devices. That is about the receiver. So, both this transmitter and receiver use the antenna to capture the radio signals. So, in real time, we are going to use radio waves. Where exactly we are going to use? Suppose take example as a car, we are using FM radio, means there we are having antenna on the top of the car for receiving the signal of radio. So, that is the example of the radio waves. At the same time, it can penetrate the walls also. So, these waves are widely used for the communication, both as well as indoor as well as the outdoor also we can use these radio waves. And these are the characteristics of the radio waves. It is used main as the phones, cordless phones, FM, AM radio transmission for both transferring the voice and data. We are going to use the radio waves. And it can also travel the longer distances and also penetrate the buildings. That is the one of the characteristics of the radio waves. And it requires a transmitter for sending the broadcast radio signal. And for receiving, we are going to use the receiver. This receiver, how we are going to receiving the data? Using the antenna for receiving the signal. That is about the receiver. And the main example for this short range broadcast radio is Bluetooth. We can consider the example as Bluetooth for short range broadcast radio. That is, we can use in computers, mobiles and printers. We are using Bluetooth, right, for transmitting the data at the rate of 1 Mbps, that is megabits per second. And what are the main disadvantages of radio signals? So, it is unidirectional and insecure. That is disadvantage. At the same time, there may be interference such as reflections from the water also. That is also one of the disadvantages of the radio signals. And the next one is the microwaves. How we are going to use microwaves for sending the data? Microwave is also a type of the radio waves, but it is having the high frequency and it can be classified as it is a subclass of the radio waves. The frequency here 100 megahertz to the 100 gigahertz, that is the speed of the microwaves. And these, unlike the radio waves, these microwaves are the unidirectional. So, in which sending and receiving the antennas that need to be aligned. That is about the microwaves. These microwaves mainly used for the point-to-point communication. Mainly it is going to be used in the point-to-point communication. This is, we can see in real time, this is the signal. This is the signal for transferring the data, that is the microwave signals. This is for microwave signals for transferring. We are going to use these. And it is mainly used for the satellite communication, navigation, radar, remote sensing and other short distances. We are going to use these microwaves. And these microwaves, the main speed is 1 Mbps to 10 Gbps. That is the speed of the microwaves. The main characteristics are, it is used for the high-speed transmission. For high-speed transmission, we are going to use the microwaves. At the same time, information is going to be sent via microwaves from the ground-based transmitting and receiving stations. And here, text, sound, graphics, these all are going to be converted into the microwaves, microwave pulses, and that are going to be transmitted. At the same time, these microwave stations means repeater stations. Repeater is nothing but Regenerating signal. Repeater. Why we are using repeater stations for regenerating the signal? Whenever we are going to transfer the data for the long distances, the signal strength may be going to be getting down. To overcome that problem, we are going to use the repeater stations. So here microwave stations, these repeater stations must be placed every 50 kilometers. For what purpose? For to receive, amplify and then pass the signal along the data. We are going to use the repeater stations. For every 50 kilometers we are arranging like this. That is about the microwaves. The main disadvantages are it cannot pass through the obstacles. That is the disadvantage. And one more disadvantage is it can only use line of sight for the transmission. These are the disadvantages of the microwaves. And the third one is the infrared waves. Infrared waves in unguided transmission media. Where exactly we are using infrared waves means these all are going to be divided in the form of frequency only. Means each wave is having the different frequency. So here these infrared signals mainly having the frequency in between the 300 gigahertz to the 400 terahertz. That is the frequency in between the signals, and these can be used for the short range communication. We are going to use the infrared waves. These infrared waves mainly for very short distance communications, like in real time we are going to use TV remotes, right? In TV remotes we are using infrared waves only. Wireless speakers, automatic doors, handheld devices, these all are using infrared waves only. At the same time, these infrared waves having the high frequencies mainly for preventing the interference in between the one system to the another system. It is having the high frequency. And coming to the characteristics, the speed of these infrared waves is 1 Gbps, 1 gigabits per the second. These are the examples for the infrared waves. See, this is the thermometer. In thermometer also we are using infrared waves, and remote. In remotes also, in everyday we are using TVs, right? For watching TVs we are using remote. So here also we are using infrared waves. Infrared waves. That is infrared waves. The characteristics are it is used in remote controls. For televisions, optical mouse, entertainment devices we are using these infrared waves. At the same time, sending signals using the infrared light wave that are going to be invisible to us and just about to the red end of the color of the spectrum. At the same time, it works over a moderate bandwidth, that is 115 kbps, and works up to the few meters. These are the one of the characteristics. IRDA port can be used for fixed to transfer the data. For transferring the data using the infrared waves, we are going to fix the IRDA port. At the same time, alternative to the short range signal, we are going to use as a Bluetooth. So, coming to the disadvantages of these infrared waves, these signals cannot be used for the long distances. So, in previous slide only we tell that it is mainly for the smaller distances. For smaller distances only we are using this infrared waves. For longer distance it can't work. That is the disadvantage. At the same time, in addition, we can't use infrared waves outside a building. We can't use, because sun rays contain infrared waves that can interfere with the communication. That's why we can't use outside of the building. So inside only we are using infrared waves. That is about the infrared waves. Now we can see the cellular radio waves. What is cellular radio waves? The speed of the cellular radio waves is the 10 Mbps to the 1 Gbps, 10 megabits per second to the 1 gigabits per the second. These are the characteristics of the cellular radio waves. So those are, it is mainly used in the wireless modems and cellular telephones we are going to use. So this is the cellular waves. So for connecting our cell phones, we are going to use cellular radio waves only. So it is having the high frequency radio waves for transmitting the voice. At the same time, digital data, we are going to use the cellular radio waves. And it can connect the notebooks or mobile computers to the cellular telephone to access the web or sending and receiving the emails. So we are using mobile phone, right? For sending and receiving the mails also we are using cellular radio waves. At the same time, personal communication services. It is a set of technologies mainly for digital cellular devices like laptops, cellular telephones. We are going to use this cellular radio waves. This is about the diagram about the cellular radio waves. So here we are connecting cell phone through the cellular radio waves only. So now the main disadvantages here is it requires the complex infrastructure. Whatever infrastructure is there, that is complex. At the same time, it has to be well planned frequency, spectrum distribution is. Means if you want to connect with the cellular radio waves, first that is going to be well planned. This is the disadvantages of cellular radio waves. And the final one is the satellite waves. Where exactly we are using satellite waves? So the speed of these satellite waves is 1 Mbps to 10 Gbps. 1 megabits per second to 10 gigabits per the second. That is the speed. At the same time, the characteristics of these cellular waves are, it is mainly used for the global communication. Wherever you are in the world, for connecting that, we are going to use the satellite waves. So these satellites are placed in the space. So it is going to be in space. We are using satellite communication and they orbit to the Earth. These satellites receives the microwave signals from the Earth station. These satellite waves, how it is going to be received from the microwave signals from the Earth station. These satellites magnify the signals and retransmit them back to the data transfer. Speed is very high. So it avoids the cost of cabling, repeater station. So for connecting this, there is no cables are needed. There is no repeater stations are needed. The transmission from the Earth stations to the star satellites means this is the Earth. So this is the Earth. This is the Earth, right? This is the Earth. For transferring the data from this is the satellite. This is the satellite. This is the satellite. So for transferring the data from Earth to satellite, we are using the uplink. From satellite to the Earth, it is the downlink. Means the transmission from the satellite to the Earth station, that is the downlink. From transmission from the Earth to the satellite, that is the uplink. So the main disadvantages of these satellite waves are, it is very expensive and it is not easy to repair. If any problem is occur, it is not easy to repair. At the same time, maintenance also very difficult. If it is weather and some spots also can cause the signal disturbance. This is the disadvantage about the satellite waves. Let us see the summary of today's session. In today's session, we discuss what is unguided transmission media and what are the different types of the unguided transmission media, like broadcast radio waves, microwaves, infrared waves, cellular radio waves and satellite communication. Where exactly we are using in real life these types, all waves we are going to discuss in today's session. Thank you.